Okay, so today we're going to have a look at perpendicular lines, following on from parallel lines last time. So remember, first of all, perpendicular means at right angles to. So here's the fact that we need to answer these questions today. If two lines are perpendicular, then the gradient of one line will be the negative reciprocal of the other. So first of all, we're going to do some practice on this negative reciprocal concept. So if I've got a number here, this is the number 4/5, then the reciprocal of that number is that number flipped, and the negative reciprocal of the number will be the negative version of it. So if I've got negative 7/3, then the first thing I'm going to do is I'm going to flip that, and then I'm going to take the negative version of it. If it's already negative, then that will become positive. So the negative reciprocal of negative 7/3 is 3/7. This one is not a fraction currently, so I'll just make it a fraction so I can find its reciprocal. So reciprocal will be 1/5. I'll take the negative version of it. I've got negative 1/5. Similarly, for negative 2, I'll make that a fraction, negative 2/1, and I'll find the reciprocal of it. So I'll flip it upside down, and then I'll take the negative version of something that's already negative, and that'll leave me with a positive, just a half. For this one, this is already a fraction, so I can just find the reciprocal immediately. So that will turn into negative 9. Notice here that I'm just turning it into negative 9 because I don't need it as negative 9/1. So I just leave it like that. And then I'll take the negative version of it, which will make it positive. This one, before I find the reciprocal, I need this in fraction form. So I'll do an extra bit of work here to turn this into 5/2. And now I'll do the reciprocal thing. So I'll turn it upside down. And then I'll take the negative version of it. So that's how we always find our negative reciprocal. So find the reciprocal, take the negative version of it. And so we'll need that throughout this. Okay, so now let's put this together. Perpendicular, and we know that perpendicular here means that the gradient is the negative reciprocal. So if I've got a line with a gradient of 3, and I know that because it's y equals mx plus c, then if I've got 3, I'll go, well, 3/1, the reciprocal of 3 is 1/3, and a negative version of that is negative 1/3. So all of these lines in here have got a gradient of negative 1/3. And therefore all of these lines would be parallel to all of these lines would be perpendicular to y equals 3x plus 4. Just so that you believe me, I've got one I made earlier here. So this is the line y equals 3x plus 4 coming through here. And I've already pre-made these two lines, y equals negative 1/3 x plus 7, which is the blue one, and y equals negative 1/3 x subtract 11. And you can see that these lines do cross at right angles to each other. They are perpendicular. Okay, so what we've got to do first time, we did this with parallel lines as well before, is find the equation of any line that's perpendicular to this, so anything at all. So the first thing we need to do is know that the gradient of this line is 5. And we know that because it's in the form y equals mx plus c. So if I know the gradient is 5, I can do the negative reciprocal thing. So 5, make it a fraction, find the reciprocal, find the negative reciprocal. So the gradient of the line that I want has got to be negative 1/5. So I can then make my line, and my line will be y equals negative 1/5 of x plus something, some constant value. We'll just go with c, but it could literally be anything, positive, negative, fractional, decimal, whatever you want it to be. So again, second one, we need to know what the gradient is. We know what the gradient is by looking at this, although it's not quite in y equals mx plus c form. It's close enough for me to be able to read it off. So gradient's negative 3. So reciprocal of that, negative version, go back to being positive. So therefore the gradient of my line is 1/3. So I know it's y equals 1/3 x plus anything. Next one already starts as a fraction, so I can skip that first step. I know it's got a gradient of 2/7. So 2/7 will become 7/2. Negative version becomes negative 7/2. Therefore it's y equals negative 7/2 x plus c. Again, this one's in the form that I wanted it to be in, so they're all in y equals mx plus c, these here. So negative 1/4 I can turn it upside down. Notice here I just need it as 4, I don't need it as 4 over 1. And then I'll take the negative version of it, it'll become positive. So that will just be y equals 4x plus c. Bottom one, I've got a bit of extra work to do because it's currently a mixed number, so I'll turn it into 9 over 4. And then we'll find the reciprocal. And then we'll take the negative version. So we've got y equals negative 4 over 9 x plus c. Done. Okay, so now we're going to do what we did with parallel lines, which is instead of finding any equation, now we're going to find the one that goes through a particular point, the one that goes through 9, 2 here in this particular question. So, same start as before. We've got a line, it's in the form y equals mx plus c. We know it's got a gradient of 3. If the gradient's 3, then we find the reciprocal and then the negative reciprocal. So that means that my line that I want is going to be y equals negative a third x plus c. But this time I know that it goes through 9, 2, so there's only one line that does this, so I can find out which line it is by putting these coordinates in, by putting the x and the y coordinate in. So let's do that. 2 equals negative 1/3 multiplied by 9 plus c. You've got two options here. Either you can write this out formally as a third multiplied by 9, or you can just read this as a third of 9. So I'm going to just for now read this as a third of 9. So a third of 9 is 3. So a negative a third of 9 will be negative 3 plus c. Add the 3 to both sides, and that gives me that c is 5. And if c is 5, I can then put that straight back in to here. So the equation of the line that I'm after, perpendicular to y equals 3x plus 5, is y equals negative a third x plus 5. And I can even do that quick checking thing like we did before. A third of that's 3, negative a third of that is negative 3, and negative 3 add 5 gets me 2. Spot on. Okay, very similar question. If you want to pause and give this one a go based on what happened a second ago, more than welcome. If not, I'll take you through another one. So it's in the form y equals mx plus c, which means there's no work to do at the start. I've got negative 2, so we'll find the reciprocal. Then we'll take the negative version of it. It's already negative, so it'll become a half. And now I'll put that into the equation of my line into y equals mx plus c. It's y equals a half x plus c. But this is only one line that I want. This is the line. I need to use these coordinates to find my line. I've got x is negative 6 and y is 3. So I'll put those in. Be sure you get those the right way around. Half of 6 plus c. So substituting in, 3 equals a half. Half of 6 is 3 plus c. That means that c is going to be 0 here. So when I put this back in, I've got that the line is y equals a half x, and it's finished. Except that's not true. I've done something wrong. Oh, I'll tell you what I've done wrong. I forgot to put in negative 6 there, didn't I? Try again. Go back. It's negative 6. Did you read the question properly? I realised that was happening because I was checking it on the end. Let's do this bit again then. Not the smoothest moment. 3 in. A half of negative 6. That's why you check your answer, kids. So then now I can work this out. 3 equals a half of negative 6 is negative 3 plus c. So now I add 3 to both sides. I get 6 equals c. And now I can put that back in. I get y equals a half of x plus 6. Now I'll do what I was doing before. I'll check this. A half of negative 6 is negative 3. Negative 3 adds 6 gets me to 3. Got it right this time. Okay, last one. This is a bit more advanced this time because this has not presented itself in a form where we know the gradient. It's not in the form y equals mx plus c. There's more work to do here. And some of you are struggling a little bit with this in the last lesson. So we want y as the subject. We want y to be positive, we want it as a subject. So the first thing to do, I need to remove this 4 and I need to remove this x. I'd probably be kicking this off to begin with, so I'll leave them with 4y equals negative x plus 16. It's helpful to write it in that order. And then I need to get rid of this 4, so I'll divide everything I see by 4. Now, rather than doing that, it's more useful in this particular situation to divide both of the bits by 4 independently, which is the same thing. So I get y equals, if I divide something by 4, that creates a quarter. And 16 divided by 4 gives me 4. Now I know what the gradient is. I can see by looking at it, the gradient of this is negative a quarter. So now I can turn up and do my negative reciprocal thing. Reciprocal, flip upside down, will give me 4. 4 over 1, which is just 4. And so it's negative 4. Then we'll take the negative version of it. And so we just end up with 4. So then my line will have a gradient of 4. It's perpendicular. In fact, it's going to be y equals 4x plus c. It's kind of a nice number here. And I can find c to get my particular line, which is that x is 2 and y is 7. So in it goes 4 lots of 2, plus 7. Don't know why I've written 7 on the end. It's plus c. 7 equals 8 plus c. I can see by looking at it that c has got to be negative. Taking 8 off both sides gets me that c is negative 1. If c is negative 1, then I can punch this into here at the top. So I get y equals 4x, subtract 1. I can tell this is right by looking at it again. 4 lots of x, 4 lots of 2 is 8, subtract 1 gets me 7. I know it's right.